Are you an architect or engineer interested in learning how to do full 3D block course layouts? Stay tuned and we'll show you how it's done. Okay, going into it, for those in the industry, we're pretty all aware of what cinder blocks are. They're used especially in the southeast for home construction due to hurricane requirements. Works out way better than lumber construction due to mass and other factors. So a standard cinder block, just showing you in details, is the 8 by 8 by 16. And when you see these dimensions, these aren't the dimensions of the block, it's the dimensions of the repeat pattern. To account for grout, these blocks are actually 3/8 of an inch smaller on all dimensions. So it'd be like 7 and 5/8 and 15 and 5/8 respectively. But for the purposes of layout, you can do it a variety of ways of just in 2D, or my preference is actually 3D. I use a system called Rhino, a CAD system. It is very powerful, very user-friendly tools. It does not get in your way and allows you to handle mass amounts of data without crashing, unlike some other CAD systems. Has some very good tools for repetition patterns, and there's even more advanced things it can do through a what do you call it, a subprogram called Grasshopper. But today we're going to be showing you some basics with this and why you would want it. At the minimum, I got a floor plan here for one of the projects I've worked on. And this is showing just that cinder block modeled, and it is repeated. And what this does is it keeps you honest with the layout. And construction cost is like really expensive, and schedules always go over. So you want to do a layout as an architect or even like an engineer, depending on what your role is. You want to be efficient with this stuff. So you want to stay on what's called block course, which is essentially an 8-inch grid for position of windows, lengths of walls, heights of walls, doors, what have you. So this is basically like a stem wall that goes around this house, and this is about like the simplest you could keep it. But here we can see these 3 blocks going like so, and then it has one on each end. So it's let's see here, that should be 4'8" right there on the inside. But it goes to show you how you can just put a bunch of these blocks down on the flat plane axis. Normally Z's pointing up when I'm working these architectural things, and it will let you do a layout that is honest for block course. So they should not have to cut blocks, and if they do, it'd be very minimal. So that's just showing the layout there, and it gets that all set up. So now you can go even more extreme. But I should point out these cinder blocks are relatively cheap and available. So you can just go to the supplier or Home Depot to get more. So looking at the next thing up is like ICF, insulated concrete forms. And we've done projects where we combine cinder blocks with ICF. Usually cinder blocks are more on the foundational parts, columns, exterior features. And then the ICF there is there for, of course, insulation. And with the wind loads, it's there for mass. You can get a lot more mass out of it for the dollar. You get a solid poured concrete wall without having to use any formwork that has to be rented and taken away. These are hollow blocks that like Legos, and they got a foam facing on each side. Let's see here. Here's a good picture, and this is the part. This is the company we work with, is Build Block. They're out of Oklahoma, but they have plants all over, including one here in Florida in the Tampa area. So if you need more blocks with this system, it is a good chance you can go get them on order and then go pick them up locally without it being a gigantic event. But it is like a lead time thing, and they are expensive for what they are. So it's not, you don't want to be wasteful with them, and you really want to know exactly what you have. So this is Build Block, showing the overview. Has 2 foam sides to it, a bunch of plastic webbing, and they stack like Legos. They literally have like little nubs on top. There's several different systems out there. Our preference towards Build Block is, being in Florida, everything is about the regulations and the paperwork. So by hands down, the Build Block and their website and their people, like resources, you can get a giant stack of PDFs and print them, put them in the building department's desk and you're set with that, where some of these others are a little bit not too well good with the paperwork. So between that and the multiple locations and just their history, it's been a good experience. But let's see here. You stack all these blocks and then put on rebar, pouring concrete from the top. That's just a quick overview of the system. And then going into other types of cinder blocks, like for columns, they got like 16 by 16s, but everything's really kind of a increment of 8 inches for the most part. There are some unique ones, like a heavy cinder block that's 12 inches wide and then 8 inches tall and 16 inches long. That's another one that's more for like a very heavy wall. But you're basically playing with Legos here in 3D. And this isn't the old days of construction where we can be wasteful and things just happen. So a little bit of digital upfront can help, and definitely Rhino is a tool for that. So going over what you saw in the title or the front part of the video, this is a barn proposal that is a hybrid of cinder block construction and ICF construction. So zooming in on this, we got these dark purple blocks showing the block course here. And this particular customer wanted garage doors specifically spaced for architectural reasons. So the hit we're taking is we got a little bit of a gap here that could be filled in. Cinder blocks can be cut, or they can have gaps, and then they get bolted over with plywood and then poured from the top with concrete, assuming that they got a good shot to get all the concrete in there. There's also some footer pads here showing where they need to go in 3 dimensions. But for ICF, you start with the corners. These dark gray ones are the corner blocks. And again, these are modeled to their dimensions too, and build block and most of the others are amplified size of a cinder block. So they're like 4 feet long, 16 inches tall, and then the width is like 11. So the width doesn't really factor into it, but from a planar view, it's like height and width. The difference is the styrofoam, the ICF can be easily cut with like hand saws or a spiral saw, something of that nature. Whereas the cinder blocks, they're a little nasty to cut. They have a concrete saw, it makes a giant cloud and mess for everybody. But going over this whole barn structure, it is set up for a combination of normal cinder blocks, and that kind of sets the size of the building. Then we're jumping into ICF for the main structure, and this ICF gets us a physical count. So you can actually physically go in here and count these, or you can do other things like these 4 courses right here are all basically the same count. So you just kind of need a count going across. It's color coded too. This is a little advanced, but the gray is the corners, the light gray is just normal blocks, and then blue is cut blocks. You can throw all that stuff into a spreadsheet and go from there. You can also do some predictive things, but if you overshoot it, these blocks are extremely expensive. There is lead time, and then you'd be throwing away a lot of stuff. If you undershoot it, you got to get things on order. Your project is delayed, schedule slips, all that stuff. So you want to try to be pretty accurate with it. So this is a good, solid sanity check. It is effort to do this, but for what's at stake for the building cost and schedule, it is probably well worth it. And other industries outside of construction, like aerospace engineering, marine, all that, they have CAD files that detail everything. So we know what stuff is digitally before they hit the go button to build it. So this is just showing the whole building overview in 3 dimensions. So how do you go and do something like this? And I'm going to start off with a very simple the pattern we'll do here, and this is in Rhino. So you go and grab basically a rectangle and start at 0, 0, and then you do a relative at, the at symbol, 16, comma 8. And again, we're building for the repeat pattern here. We're not doing actual blocks with the grout, so we're just trying to get the repetition pattern here in 3D, so it keeps you honest with your layout and you don't have surprises later on. And then you go over to solid tools and extrude. And then we take this and we go up 8. So there is our first block. From there we can take this curve, move it away, And then Rhino gets pretty powerful where there's a variety of things you can do, but usually a good thing is copy. And we can just take this, move it over, right click, click it again, grab both of them. And then it's like exponential when you do it that way if you wanted to, if you had like a lot of these to do. So just showing that. And then let's say we want to get this block course going the other way. We can move it over with the gumball, with the move. Go hit the blue rotator thing on the gumball, go 90. And now we can go in and it's all pre-highlighted. We can do a move, MOVE typed into the command line up top. Go to this corner, go to that corner, and you're literally like playing with virtual reality Legos in a CAD system. There are other CAD systems that can do this. Some people might find this unconventional, but with the brutal realities of construction, this is some homework that's well worth it for planning, scheduling, efficient layouts, not wasting materials, not wasting time, and definitely not making giant clouds of concrete dust all over your job site. So let's see, we can do more of this copy pasting. This is a very simple building that we're doing, like a shed. Let's just call it a garden shed. So we're going to want to bring it over here like so. And then we'll want to grab, and with Rhino, you can flip over to the top view, something like that, just to get it locked in. And then we can do a repeat of copy. So if you hit right click, it will just bring up whatever the last command is. And we go over here with a window that goes right to left and top to down. It highlights everything. And now it's hunting for where do you want to move it from. And it's just like a trick or a pattern in your head that you got to get used to. But it takes out all the math and stuff like that. You're letting basically this layout do things for you. So now you have a building that could be built. And for most people, this is where it would stop. And from there, like you say you wanted to put in a door in this area here. So that's a 16-inch block. Yeah, two of them would be 32. Four of them would be 48. So something like let's just call it a 3-foot man door. That's going to cut into one of these. So let's just say, we'll take this out, take this out. We'll just delete them. We want them in this area, and then we want to grab this guy. And with Rhino, it's like magic. So they also make an 8 by 8 by 8 block as well. So this thing's 16 inches long. So you just go on the scale, 0.5. Now you got an 8 by 8 by 8 block. Moving back over here. And so you can do this for like your first course around a building, and then most people should consider this as efficient. You can go full crazy, like full 3D. For normal cinder block buildings, that may not be needed. You might do something for height too, just locally, just to get you for where like a window or a door, so the heights are on an 8-inch grid going up as well. Go back here and let's go get a measurement. Distance. So you type in distance, and with Rhino, like anything you'd think up, like Tony Stark with the Mark 50 Iron Man suit, you like think it, you type it in here, and it's going to cough up whatever the command is. They also give you ribbons, they give you pull downs, they give you anything you want, like any style of interface with the software, it lets you do that. So going over here, and this door is 40 inches. So for a 3-foot door, that should work. It could be bucked on the inside with lumber and so forth from there. So that will show you how to do that. And let's see here, drafting, linear dimensions. So you can go over here like so. 136. Rhino will convert these to, foot and inches, architectural scale. I recently upgraded to Rhino 8, so this is new stuff, but I'm really liking upgrades. I've been with Rhino for 10 years now with this software, starting with 5. But yeah, you can go in here and get some dimensions. And then if you want to, you can like just say you got your block course, you know what it is. We'll zap that thing out of there. A new layer, CBS for cinder block system. They also call them CBS or blocks, either way. they'll call them those things. Go highlight everything, and then we'll go, let's see here, change object layer. So now they're there in the layers, and we can hide it, we can bring it back. So when you go to do drafting on here, you can go, actually I'll start at the door. So go over here, 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 there, and there. Let's just say we got an inside wall too. And see, you're using these things almost like a template or a guide, and it's keeping you honest. That's the main thing. You're not trying to think about, is it, 8, 32, 48, whatever the numbers are. Here's lay out the blocks like Legos in 3D, and you have something that is accurate. So we hit it and go to top view here. Let's hide the grid. So we're going to show the grid now, show the grid axes now. So now you got to start to it. That could be the start of your, floor plan, foundation plan, whatever it might be. Again, with the Rhino, it's whatever command was in there. Right last was enter button or right mouse click. It brings you right back to it. So it's just super fast. You don't have to hunt for menus. And Rhino's really based, if you don't like something, you just back out of it, do it again really quick. So that's where you can get some speed. So that's showing the floor plan here. Very simple floor plan. And then from here is probably more where you draw actual dimensions on something. So we're like 11 feet or something like that. We're under 144. And let's see if I could do some other stuff. Some of this might be hunting for things. I might have to come back to this later, but you can definitely, a lot of my heavy work was in Rhino 5, but with this recent upgrade, they have moved some things around. But that's going to show you on the simple case, like how simple it could be to lay out some cinder blocks, get an accurate building layout, and go from there. Let's see, turn the cinder blocks back on. Let's just say we want to make this this doorway accurate for like a 6 or yeah, was it? It's that 80 by 36-inch door. It's like kind of a standard door. Since the block course alternates, I'll show you how that happens here. So back on the gumball, it's like 8 up, and I held the alternate key to make a copy of it. And then if you don't want to copy it, you just click on whatever thing you're working for, -8. So the blocks are going to be alternating like this. But again, if we're going for the quick and easy and you want accurate like window placement, say, we're going to go grab the 2 bounding blocks like so, which is alternate, no, it's shift. So it's a click, a left click, and you hold the shift key and you can collect multiple objects. So if we go on the blue vector, which is Z axis, we hit 8, it's only going to take it up 1 block course. Of course, block courses going vertical, they're going to alternate, making the classic brick pattern. So go click on it with an alternate, and we're going to go 16. So that's going to take it to 16. I'll just do another 16, and the old number is still in there. So all you have to do is click on it, and you physically have to change it to go something else. So go up like so, and we might be high enough. Some of the stuff's just eyeball it, like you can memorize it in your head. I think that's high enough. So let's do a distance. So we go over here and we go to the ground, 72 inches. So we go here, we go to the ground. That's at 80. So that's where that needs to be. Let me show you another product here. And they got different guys that make it. But down here in Florida, it's called Castcrete. So Castcrete lintel. U-lentils products. So if you're in the Southeast, I'm sure you've seen this symbol before. Products. So long story short, these with normal masonry construction, here's an excellent graphic. They have lintel, it's a lintel, so it's like a concrete beam that's pre-made. The masons will put it in place. If it gets really heavy, they crane them in, but usually they'll have guys, a couple guys lift it up and they'll put it in place. So the key things really are these lintel headers. And you can see this is all on block course, just like I'm showing on the CAD system. And other things too, you might have a bond beam on top. So there's a couple different ways to do that. So here we got a U block that these cinder block manufacturers make. They call them a lintel block as well, I think, or bond beam block. So that would be a typical top course for that, or they could just, power nail on some plywood on each side and make this thing pure solid concrete on top. But going back to these lintels, you can see that they are held on by 8 inches on each side, or basically our basic block course grid. So you can see the size of that. We go back, and what this is going to do is we can get 3D lintels in space too, because these things can be procured a little bit easier than, let's say, like an ICF block. They're more like standing around. They're going to come from a big, concrete plant that has them stocked. Cemex, I know, has them. You can go there to get the block, these lintels. But let's go back to our thing here. Oh, the other thing I was going to say is they make lintels with a notch in them for situations like a doorway lintel. Let's see if we can go cast, create, lintel, doorway, images, U lintels. Hoping to find a picture of this. I should have brought one up in advance, but they have ones with the notch in it so you can actually get, here's an actual picture of what all this stuff looks like. And you can see the conventional block course pattern. And then you get into situations like this where you might just be double stacking things with the seam locally. That's okay for a small amount, but it's the main wall is going to have the conventional cinder block pattern. So let's see here. They make a U lintel. I know I've seen it. But I can jump back into the CAD system here pretty quick. Just want to look at a couple things. They also make doors that will fit in there, but when you're working with it as an architect, you just got to make sure it's going to fit in the space. So we're 80 inches, which is roughly where the doorway is going to be, and then you got to procure that exact lintel that's going to work for you. But this is going to help with that. So just going over here, and I go click the midpoint. That puts me at 8 inches from the edge. So you can see it's all over there. And I go around over here, like so. And then I'd extrude it again. That's one way to do it. And then there's another way directly within solid. This thing basically does the same thing, so it cuts out the sketch. So we go from here to there and up, and bang, you got your lintel. So now you can, and then you go click on it to get rid of the old blocks, and it's going to give you options. So we get rid of that, get rid of that. Now we got our lintel, it's in place. So that's going to show you that if you do get a U lintel, or sorry, the notched lintel on the bottom, I'll go model it really quick just so you can see what that would look like. Bring back that old block too. So I'll go back to the same command, I think. Let me think what I'm going to do here. Do a different way. I'll do standard, just because I want that line. I want the line in there. So that's in there. And then I'll go, just say move this 10 inches away. So he's clear. Get rid of these. And then we're going to go back to solid and extrude it. And you can go in either direction, but I want to do something particular here. I want to go both sides, and it's like 2 inches. So this is going to be a subtraction object. And we come back over here, and then we go back -10. You can also do grids too. Let's see. So we're on a grid. We can grab this guy and we can move it. It's moving it 1 inch at a time. If you zoom in on it, so I can bring it back to where it was without it being disturbed. So this is a subtraction object. We go to, it's a Boolean difference. Other CAD systems might call it Boolean subtract. So the workflow is you click on what you want to subtract, right click, what are you going to subtract it with, which is this guy, and then another right click. It's gone. I can delete this. And then I made like a duplicate because of how I asked the questions. So I want that. Bang, there you go. So, depending on how that goes, you just get accurate with like what kind of door you're going to put in there. The other term they throw out is commodity windows. Commodity windows is code for a standard size window. Why they can't call it a standard size window, don't know. If you go into any window shop, you say standard size window, they'll look like at you like you're a space alien. But if you say commodity windows, they're like, ah, we know what you're talking about. And those can often jive with the block course, the 8-inch block course. They'll put bucks and windows typically around them to attach it to. That's usually pressure treated. And again, this is all like southeastern United States kind of construction, but it goes to show you the factors to look at, what to consider when doing this kind of stuff. But hopefully, this will give you some new tools if you're an architect, if you use Rhino, especially if you're Rhino's very popular with architects. So um, maybe this is something you've never considered before, but I'm an engineer by trade, and you do math calculations and all that stuff. It's fine, however you want to say it. But using a tool like this, when you really get into it, the big thing is it keeps you honest with your layout. So you're using like a snap, three-dimensional snap thing like you saw. We can move them from corner to corner. If we know the numbers, we can do 16, 32, 64, amplify it from there. But it just gives you a good accurate layout. And this goes to show you don't have to model every single block in there. You just get your doorways in there. And now we know what size lintel we need without doing crazy math. So if we need to order our lintels, we can go in just distance again, grab one end, grab the other end. And we're at 56 inches. So, since it's feet and inches, just so to show you, it's 56 divided by 12. 4.666 minus 4. 6666 times 12. 4'8", in case anyone is like trying to, go by feet and inches, in case that's a new thing to them. Growing up in construction, this is all secondhand nature. So you can go from like a simple little cinder block shed if you wanted to, with like this with a doorway, maybe a couple windows, to full on crazy something like this. And it's all what's appropriate for the task. I think most like architecture firms, they'd see something like this, like, hey, that's a good cost savings or sanity check for what we're doing. Um, for a huge cinder block house, you wouldn't do full 3D everywhere, just because of the low cost of cinder blocks, the ability to move them from site to site, and no lead time. But definitely, if you're hopping in the ICF, that's where things get a little more scientific, just because you could have tens of thousands of dollars of material short or extra on a job. And these blocks, they're not quite like cinder blocks. You kind of want to get them off the pallet, put them in place, and pour them because it is styrofoam. But with the ICF, should also point out that they'll put bucks around the whole perimeter, usually like a 2x12 ripped to the width of the ICF block. I can put some pictures of this in a later video, and put it across all the sides. And then they'll have a whole like rebar cage. They also call them lintels, which is like these, or stirrups, like these C or S-shaped pieces of rebar that go over in this above this area here with a bunch of other rebar in it. And then that's how that makes that beam structure in there. And again, the ICF stuff is a lot more friendly for cutting it where you need it. But again, this is to give you a good, what do you call this stuff? Counts. You can get counts from this. You can count for the doors. And it also goes to show you how you can mix the two, because the coursing is the same. It's all based on 8 inches. You can mix and match this kind of structure. So if you have exterior decks, you can do those on conventional cinder blocks. You can take those lintels and put them right into the ICF with trenches. Your specific architect or your engineer is going to give details on that, but as a layout person, this helps. This also helps tell the story. The other thing too, when you're dealing with ICF, it's a kind of a niche construction. It's not as widespread as cinder blocks. So a CAD model like this can help a lot, and you can just take some screenshots and give it to the foreman via a text message, so I can bring it up if they have questions. for something, they can see it in virtual reality, and I'm like, oh, okay, this is what we're all talking. Everyone's on the same page. The other cool thing is with Rhino is they have an app for the iPhone. They might have it for Android, where you can take the native 3DM file and send that through the cloud, method of choice depending on file size, and you can open it in the Rhino app, and you can spin this stuff in 3D on your phone on the job site. So that's a huge thing. You're getting to see everything in three-dimensional um, views. Construction people are very visual, and the old school, 100, 200-year-old practice of drawings, it only gets you so far. So something 3D like this can help with the situation. Even something back to our simple shed, like this should be visual enough to understand what's going on. It's pretty simple. So hopefully this will help everyone understand utility of Rhino with architecture, construction, engineering, and design layouts, particularly with its grid capabilities, just to make an honest layout that you don't have to worry about it not being right. You do have to make sure things are snapped correctly, like you could have a block fudged like that, and you have to watch out for that kind of scenario. But overall, it's a very useful tool that this method has proved very helpful on several builds that the company's done so far. So hopefully this will help you with your firm, the things you're doing with construction, even if you got Rhino and you're doing a someday dream of a building, at least you can make something accurate and visual in 3D and understand what it looks like. It goes to show you the commands I've showed you today are fairly simple to use for Rhino. And best of luck on your project. So get after it.